I used to be able to make this joke when I was young that like I got into computers for the women and the money, like because there was no fucking women and no fucking money. But like now that there sort of are some women, and also there's
Now
a
there's
really
money.
money. So
Yeah, now there's money. Yeah,
yeah.
so I don't know about the woman part, but there's money.
What's the name of the damn thing again? It's coffee, computers, and beer, right?
Yes.
Killer. Can I give it a shot here? All right. Welcome again to Coffee, Computers, and Beer. I'm Keith Adams here with my good friend Julian Verligay. Rocking the coffee, rocking the beer, time zones. Today we're going to talk about these newfangled machines that think and code, and kind of what they're doing to our industry.
Actually, maybe you said thinking. That might be the first thing to talk about, right? Are LLMs thinking? Because I hear a lot of back and forth on this, right? There's a lot of smart people who say they're just applying patterns. It just they just happen to have ingest so much data that it looks like thinking,
Yeah, yeah.
right? And others who say, no, that's genuine intelligence. And anybody who says otherwise doesn't realize that us humans are exactly the same, right? Like we use
Yeah,
the data
yeah.
that we. So what's your take on that?
Intelligence, not a technical term, right? Computer scientists, we don't have some special meaning of intelligence that enables us to say like, oh, this system possesses more intelligence than that system. There's no like grand unified truth. The field where intelligence is maybe a technical term would be psychology. Like if you're into psychometrics, they have a test that they administer. It's called an IQ test. Scoring higher on it means you're more intelligent by definition. If you're curious, like if you give this thing to like cutting edge LLMs these days, they top out around like 140 or so, depending if it's like textual enough, if it's one of the ones that kind of is more language oriented, which is like a smart person, right? It's one of the smart people on your team. It's not a world beating super genius or anything. So do they think or are they intelligent is kind of a vibes based question in a sense. Like I don't think I have special insight into this, but that said, um, I think it's even if thinking is not literally what they're doing, it's interesting to me that it's at least not a misleading metaphor for what the computer is doing, and that's the first time that's been true. Like as in as a normal person trying to think about like your database query and why it takes so long, if you're using the idea of thinking to try to understand why Postgres is running your query slowly, you are confused and you are going to spend a lot of time debugging something in a way that's not going to work because you need to understand its query plan and like other mechanistic stuff that has nothing to do with intuitions around thought. Whereas if you're trying to understand why, your agent isn't able to reliably like parse your calendar and figure out who you're about to meet or whatever, thinking analogies are actually going to be sort of helpful. Like it might be that it is forgetting, it might be that it is getting confused, it might be that it is, been given an ambiguous instruction you need to clarify. And thinking is, cognitive metaphors are actually instructive and helpful there. So I think it's a useful metaphor both operationally and kind of intuitively for what the darn things are doing. So is that thinking? It's like a kind of thinking, probably. It makes intellectual progress on intellectual problems that are ill-posed the same way people do. What do you think?
Yeah, I think they're not human. And we shouldn't forget that. And that's, I guess, where most people are confused, where they believe that these things, if they don't behave exactly like a human in every single circumstances, then they cannot be considered as thinking things. But for me, what matters is, can you tell the difference? You
Right,
know,
right.
you have, I give you a human being, or I make you have a conversation with an AI, and after 1 hour, you're not able to tell me the difference, then why does it matter what the definition of AI is, as long as to you, you're experiencing the same thing, right? Like it's like
Yeah,
in maths where, there's this definition of equality where if for all property P, those two objects, all the property that are true for one are also true for the other, and vice versa, then you can say that they're equal, right?
yep, yep.
So that's a line of reasoning that I'm applying here, where I don't want to go and look inside of how the LLM thinks, because if you do that, it looks like nobody really can understand what's going on in there. I mean, unless it's simple things. So the best way to approach the problem is go like, well, can I tell the difference? There is one thing where you can tell the difference, and that's when you ask the LLM to think about the world. And so that's something that Jan LeCun, that we both know
Yeah.
pretty well, has been talking about a lot, and actually went off and built a startup around it to build a system, I believe it's called JEPA.
Correct. Yeah.
And the idea is, the missing link for LLMs is that they don't understand the world. And so if you ask them to reason about the world, they, they're not going to be able to, because the only thing that to them, the world is just words, right?
Yep.
However, I think it does not make LLMs not interesting until they can understand the world, especially in the world of coding. I mean, you don't need that intelligence to understand the world to be able to code well. That's
Exactly.
basically what I'm saying. And so that's, I think, why we see LLMs having a ton of success in the coding world, because in the world of code, it's all self-contained. It doesn't need to know about the outside world.
Yeah.
And so the LLM can go and has all the data it's need to conceptualize what the world should be.
Yeah. There was a
If that makes sense.
Yeah, absolutely. And if I can tell like a dumb story about something, there'll be lots of stories like this along the way of things I tried that didn't work, by the way. So, a dumb story of like the early days of Facebook AI research, which I started with Jan about 13 years ago now, because we were part of the generation. I was part of the generation of people that got excited about AI because of what was going on in the ImageNet competition back in 2012. There was this model called AlexNet that kind of wiped the floor with all these specialized computer vision things. And it was built by people who were kind of neural net people. They weren't really computer vision people. And, it was this fascinating thing. And it was really clear there was an engineering paradigm there. You could like pour more data and pour more parameters at it, and it would just work better. And you could do that on hardware that you bought at Fry's, which we literally did, right? We went and built a gaming rig basically at Fry's, and, could sort of show, oh gosh, there's lots of headroom here. But, I've thought that this moment where superhuman coding machines surround us was coming for a long time. But I thought that that putting all of natural language processing, which was completely unsolved at the time, right? Like if you asked a computer to try and like translate a sentence from Chinese to English, it couldn't do it. If you asked it to try to summarize a paragraph, it couldn't do it, and so on. So saying like we're going to put all of natural language processing in the way of solving coding seemed crazy to me, because coding's in this formal land, right? There's this world of little abstract machines we can fully describe. And real programming languages were too high entropy too, right? Real programming languages have all these characters in them and curly braces and blah, blah, blah. So I thought like what we'll do is we'll just make like a dumb little virtual machine. We'll make like a little stack VM, and then we'll sort of beam search and do like old fashioned AI crap to try and make a model that can write little increasingly complicated little programs for this thing. And we'll start off by training it on some curriculum of like, make me a function that adds two numbers, make me a function that subtracts a number, and so on, right? And this doesn't work. Like this just straight up didn't convert, right? Like I kind of there were no tools available to us at the time in hindsight that were going to make this work.
So wait 1 second. How did the AI understand the instructions? So you say make a function. So there must have been some natural language processing in there, right?
Oh no, it had an output space. So instead of sort of having a softmax across 65,000 tokens, it has softmax across like whatever 10 stack machine instructions. Does that make sense?
No, I understand, but how did it understand the instructions when you say make me, something that adds 1 to 2? How in what form did that come?
Imagine you have a 10 instruction VM. This thing's output was a softmax over 10. Like this thing's output would be like instruction 1, instruction 3, instruction 7, instruction 8 is return. It was able to figure out that it should end with return, that kind of thing. This didn't work, right? So don't worry about this too much. But it seems sort of so much simpler and so much more tractable. The only problem, of course, is like, where do you get the curriculum of more and more realistic and richer programs? Well, you don't have one, right? And it's hard to like go harvest one from the wild. And what would you do? Like compile language down. We ended up solving this problem round tripping all the way through all of natural language, right? Like round tripping through like, this thing can speak every language in the world. It's read every website in the world. It like has read every program on GitHub. It has, it's great at Forth. It's great at Lisp. It's great at, whatever. Extremely shocking to me and extremely interesting and extremely crazy. And to prove that this is like, I guess by way of admitting like how stupid and wrong I've been about this stuff for so long, When I was at NIPS 2014, it was still NIPS, it wasn't NeurIPS yet. And Ilya gave his sequence to sequence learning talk. Okay, he gave this talk that like got the Test of Time award at NeurIPS 2024, and it was basically LSTMs, right? So kind of like spiffied up RNNs, right? Kind of what we used to do language modeling with, and this paradigm of quote unquote sequence to sequence learning, where you're saying like, hey, if you can frame a problem as here's a bunch of input sequences, here's a bunch of output sequences, here's this recipe for how you can sort of generally solve problems that have that shape. And then the paper itself, like, basically solved pretty convincingly translating sentences between, I think, like, I forget what language pairs were, but I think it was like Chinese and English, which is hard, right? And it was one of those things that made NLP people pay attention because people have been trying to do that for a long time. And so, his talk is sort of like 5 slides about this amazing translation system and this model he built that built it, and then sort of 10 slides that are like, oh, and by the way, this is how AGI is coming, right? And by the way, this is how we're solving the whole kit and caboodle. Are you in or are you out? I was shutting down a bar in Toronto with Ilya later that night, basically, right? And I was so pleased with, like, this is, I still think this is like the cutest little thing I said, which was like, oh, you're just going to predict the next word. And so you'll be able to think about everything because, like, the last word in a murder mystery is who did it. And to, like, say that the last word is, you'd have to understand the whole story or whatever. Cool. This glass of beer, like, all the corks in it are in conversation with all the corks in the universe and, like, gravity and blah, blah, blah. So all we need to do to, like, make the world's perfect world simulator is, like, really nail this, like, glass of beer simulator. And then the rest will take care of itself, right? Like, and I swear to God, Julian, I'm not even, like, sure what's wrong with that rhetoric. Like, I'm not even sure what's wrong with my reasoning. Like, I still think that's a pretty good reason language modeling as a project for AGI is a dumb idea. Except he was right and I was wrong, and here we all are, and we live in his future, and, like, like, it's just a crazy world.
Well, we don't really know if he was right or wrong. What we know is that what the approach they had is working. Now, I think there are many things to be said here.
True.
The
There is
first one
nuance.
is,
You're right.
yeah. So the first one is, falling into the trap of, hey, we have systems that are better at understanding a certain problem, and maybe we shouldn't re-encode everything from scratch, or let the AI reinvent everything from scratch because we know better. This is like a recurring theme in pretty much everything, right? You had people building, expert systems with a bunch of rules.
Yep.
And then, and not just that, like pretty much everything, like in every single game that, had to be beaten, they all started with a rule-based engine. And then eventually they taught the machine, the AI, how the game was working, and let the AI rebuild all the rules. And then this stuff was always better than anything that came before that was rule-based.
Right.
So I think there's an intuition there that makes sense. And everybody fell into this trap, right? Like the trap of, well, we have systems who know how to parse a file. Surely this can help, a computer. We don't have to relearn from scratch how to parse, right? And counterintuitively, actually, you don't. You probably want the AI to have the full pipeline, because if it does, it has a full understanding of what's going on, and it understands things in ways that are different from us. And so oftentimes letting the AI do its thing is not, is actually what you want. The second thing I would add is your glass of beer analogy is good, but I would say you might not be wrong. Maybe what happened, if I went to keep on with this analogy,
Yeah, let's go.
is that they got the glass of beer right. They got it so right that everything in the room looks okay.
Yeah.
So when you look around, the physics still works, etc.,
The
etc.
reflections of the pub,
reflections, and if you start looking really closely, you're like, In fact, it doesn't have to reinvent all the physics. It just has to give you a convincing image of what the bar you're in looks like, right? And so you look around and the physics seem to match. And if you look really closer and start asking really, quantum physics question, things are off, but it doesn't matter, right? If you are with your friends having a beer, you're not going to see the difference. Maybe LLMs could be that, right? They could be something that give the illusion of understanding the world enough that it's good enough for certain things, basically. And it doesn't mean that it truly understood the nature of things that we are working with. And in fact, pretty sure it didn't, because you can run those experiments. Whenever you ask something about the physical world that is clearly nonsensical, the AI doesn't pick it up, right? It doesn't see. So Jan, I think, had examples where you just describe where you're going, but I think the most common one, which I tried 2 weeks ago again, was should I go wash my car on foot?
Right.
And the AI is going to say, "Oh yeah, of course you should.
Good for
This is a great
cardiovascular
idea."
health. Yeah, saves the environment.
Exactly. And for somebody, has 114 IQ, you're like, that's a bit disappointing that
Right.
you wouldn't pick up the fact
Right.
that this doesn't make sense. So to summarize, I would say two things. One, the first one is this instinct that to go back to symbolic computation, because we have computers manipulating symbols really well, is a natural instinct. And I think the jury is still out if it's really never going to be useful. So, for example, in maths, I wouldn't be surprised if, you had, in fact, I know people working this way already today, where the AI is trained to produce theorems, but then we have, formal verification engines that verify the proofs. And if they are correct, then they're validated, right? So I think a mix of AI, rule-based, symbol-based thing is probably going to be the most powerful in terms of reasoning. And so that's first thing. Second thing is reasoning about the amount of data that is fed into an LLM is very difficult for a human being. It's a little bit like, when people talk about different timelines, like when they talk about the dinosaurs and they say 65 million years ago. And given how our relationship to time, I don't think anybody has a good idea of what that is, right? Like we have we know it's a number and we can think about it rationally, but when it goes beyond 100, 1,000, 10,000, 100,000 already is pretty hard to, but millions of years, it's just an amount of data that just we're not used to deal with. And so that's part of the problem with LLM, right? Like the scale makes it such that it's very difficult for us to reason about what's going on.
By the
right?
way, I did the Fermi exercise on this yesterday, it so happened. So I have this at my fingertips right now. So most human beings by their 18th birthday, it kind of depends how you estimate or whatever, but humans in the first 18 years of their life probably hear about 200 million words of speech, about 200 million, right? Which is a big number, right? Like you're saying, that number seems large. So it's a little bit closely guarded secret, but I think Llama 4 on its model card has said how much training data was used for it, and it is 20 trillion tokens. So that's another big number. You're like, oh yeah, this big number, that big number. But we're talking about a 10,000 times larger number in the case of Llama 4, right? So that is 5 orders of magnitude, 10,000 human lives, right? 10,000 birth to adulthood lives anyway. More data and more kind of sample inefficiency that the LLMs have going for them. So, encased in our skulls, there is, some machine that does lots of other amazing things and also is 10,000 times more data efficient at learning language than these contraptions we've put together. So to me, that suggests that there's a difference in kind, not just a difference in, in speeds and feeds, right? That this isn't sort of just a slightly more sped up version of whatever it is LLMs are doing. So I'm very sympathetic to this
Yeah, and
perspective.
we should probably not. That's why we should probably not try to copy humans and do, have different kind of AIs doing different kind of things. And, exactly like you don't necessarily copy nature to build better tools. Nobody tried to build a car with legs thinking, hey, horses have legs. So, surely that's the better way of doing things. I think, there will be different kind of AIs doing different kind of things, and that's okay. So first of all, I'm not sure I understand fully what AGI is, to be honest. Is it something that's better than every human being on Earth at everything? Is that what AGI is?
This comes
if
back to kind of
that's
intelligence not being a technical term, right? I think we
yeah.
probably know it when we see it. I think there are practical senses in which like the right setup around um Opus 4.7 is a pretty general, pretty intelligent system, but there's all these there are all these caveats around that, and it doesn't know what it doesn't know, and it's an amnesiac, and it can't learn without an external memory system, and so on.
So what do you think this implies in terms of programming languages, etc.? I'm curious to hear your perspective. What does programming look like in 5 years or 10 years from
What a
now?
great question. I think like this is actually something I'm curious about your perspective on as a language designer too. My view of kind of the craft of a language designer until right now has been that you're bridging this world of sort of formal languages where there's math and there's type theory and there's, what can and, formal grammars and whatnot, to some sort of essentially applied psychology, right? Something that's sort of essentially like, okay, this is ergonomic for human programmers and groups of human programmers to use to make, coherent, maintainable, decent systems with good properties, right? And I think there are a couple of like interesting examples. I think of Haskell as one of them, honestly, and also Rust of like, to me, people proving that this notation kind of matters, right? That this notation can kind of channel your energies in ways where it's like actually much more likely to produce something safe or correct versus sort of a completely, the first folk notation you might come up with, like basic or something, right? What I'm wondering is like in a world where like I'm going to admit, and this is partly because I'm mostly building internal tools for my VC team, right? Like but I guess we've got projects that are public and other people use them and stuff. So I think of it as real coding now. And in many cases, I'm not really poring over every character that the model is pumping out, right? It's good enough for me that the test coverage is there. It's good enough for me that it demonstrably works end to end. And so in that world, like, who is the audience for a programming language designer? Is the audience these new kind of alien minds that we were talking about that are very different from our brains? And if so, are there way better languages to make for them than the ones that they were trained on? Or, are we in a equilibrium here where just because Python and JavaScript are what these things are trained on, it's going to be Python and JavaScript until the end of time? I'm curious, like, what your thoughts are.
We still live in a world where most of the code is reviewed by humans. And so that psychology that you're talking about is still there, but not as omnipresent as it was before, right? So before, the human was really the center of the programming activity. If the design, implementation, review, all the programming, not just the coding, is done by an LLM, and human beings never have to intervene, never have to understand what's going on in there, then I think it would be the right time to go revisit how these things work. And even if we knew it was the right time to do that, it would probably take time because of the sheer amount of data that's out there to train LLMs to program in TypeScript and Python. And so I think for the foreseeable future, AIs are going to be better at TypeScript and Python, and the first ecosystems that will program, using AI. And when I say program, I don't just mean coding; I mean all the life
Right.
cycle. Are probably going to be centered around. If I would have to guess, I would say TypeScript, but the Python people are going to hate me for it probably. And my line of reasoning here is that Python is too slow. I would say if I compare the two, JavaScript is just winning for two main reasons. The first one is that there is TypeScript, so there is a whole ecosystem with types. Those types are not perfect, they're incomplete, but we'll be able to do much more tooling around that. And the second one is the JIT. Given that JavaScript is JITted, that means you can iterate a lot faster, and the code is going to be just much faster than Python. So I think the first ecosystems won't be able to break free from human psychology, if I can put it this way, just because there will be so much training data and still humans in the loop. And they won't want a system where they cannot understand what's going on inside, right? And that's going to be for a while. And then maybe one day, let's say for a few years, AIs have been very good at maintaining systems all the way through, and no human being ever has to, go in there and figure out what's going on, then probably it will be time to, go look at how to design languages that are better suited for AIs. And again, I don't know if a human will be the right person to do this
Yeah,
design. I think
it'll
probably,
be AI.
an alpha.
Yeah, self-play.
Yeah, probably an alpha,
That self-play setup.
like
Yeah,
AlphaGo,
yeah.
right? Like you teach the AI what programming is, and then you let it figure out how to rebuild all its own pieces. That would probably be more efficient. But
I mean, you can also imagine
we're
a
not
world.
there yet.
You can also imagine a world where like there's still, Python or JavaScript available as like a skin on whatever it's actually thinking or something, or like it could be a presentation layer for a human code reviewer, whereas like what it's actually thinking is, squiggle, squeak, Unicode, code point, some other spaced out thing that like we're not well posed to understand. But
Yeah, it's true. That's a bit like hardware works, right? Like it exposes an instruction set that really has nothing to do with the real instructions that they're running. So you could think of something like that, right? Where they show us TypeScript, but the way they reason about it has nothing to do with TypeScript, because under the hood it has been translated into something else. And in a way, it's already what's going on, right? Like you could say that the inner weights are pretty much that, right? Like the input gives us something, but then those are translated into vectors, and then all that stuff, is interpreted in a completely different way. So one could argue that this is already what's going on. So there's a psychology. What I'm more interested in is what kind of properties those AIs would be interested in their programming languages. You tend to focus, because the stuff that helps us reason, I don't know if it will always help AI reason. And the stuff, so there's the syntax and how things look and how we can reason about those things. And, it's pretty clear that that is very
yep,
important,
yep,
because if you have the right notations, you can express problems in a way that are much easier to understand. But then there's also the static properties of the language, right? Like what kind of properties would an AI want? Because, for example, Rust has a much more static properties than TypeScript, and yet most AIs don't seem to be as comfortable with Rust as they are with
right,
TypeScript.
right.
And
That's been my
so,
experience at least, and I think that's probably down to the data, right? That's probably down to Rust sort of being kind of minority language still.
but we don't
We
know
don't.
that, right? We don't know
We don't.
that. We don't know that if
Could you
it's
do
the
an
data.
experiment? Like what would the experiment that sorts this out be? Would it be like,
It's expensive
yeah,
experiments,
yeah,
right? You'd have to train, I guess, the same LLM on the same corpus, one corpus in TypeScript, the other corpus in Rust, but same amount of code, and then compare its coding abilities in one or the other.
yeah?
But I guess it's too expensive of an experiment for anybody to run it seriously.
I mean, we could say a few
Um,
first principles things here too, by the way, Julian, that I think like are a little underappreciated, even by like I think of myself as pretty, coding LLM pilled or whatever. Like I fully accept these as like a automation factor that's never going away. It's just too much of a
Me too.
productivity tailwind. Like it's definitely part of the world. But there's stuff that is part of normal programming that I don't think they do super duper well on yet. And one of those is actually just working on big programs. So even the kind of big context windows that you get now, like a million token context window, is enough to put several full length books into, for instance. It's not enough for big code bases to fit into, right? So we when you were working with Hack, you were supporting a code base that was on the order of 100 million lines of code. Those are lines, not tokens, right? So let's say a billion tokens. And it's not within sort of foreseeable technology right now that a billion token context window is going to be tractable. So there's going to be some kind of memory system that supports reasoning about the whole program, or you're going to need to do the thing that humans do, which is try to make the program locally coherent, right? Try to make it so that, okay, I only need to know like this thing and the things that it touches to be able to make changes that are very likely to be correct. So, I mean, I think that's one of the properties that I don't think the LLM psychology being different is going to massively change. I think it's still going to want things to be locally, contained and coherent.
Yeah, that's true. But to keep things locally maintained and coherent, what does an AI need that is different from a human, right? Like, so we can go back to these eternal debates of, dynamic programming versus static, not dynamic programming, sorry, dynamically typed languages versus statically
Right,
typed
right.
languages, right? You'll have the programming language folks who will tell you, I don't need a type system. I have my unit tests, and I'm going to have to write tests anyway. So why do I need this thing that wastes my time, right? And then you say, okay, but maintaining unit test is actually more expensive and slower than having a type checker telling you the stuff that you have to fix. And unit tests are not perfect, so they could miss some things that the type checker is not going to miss, right? But the same people are going to tell you, yeah, but it's more flexible for other things. I like my dynamic language because I can cheat whenever I want to. And, different people find different balances. Some people just prefer that flexibility and some others don't. And for human beings, I think it comes down to personal experience, personality,
The kind of
the
code you
type of
work on,
programs you're
exactly. Yeah,
working
whether
on.
you're working on something that
Exactly.
outlives you or something that's going to
And
be thrown away
so
next week.
Exactly. So I'm curious of how the AIs are going to, you know, um, what kind of boundaries they'll need in order to split up the problem into smaller pieces. My experience so far, because I've worked on this for a year and a half now, something like that, is that you want basically to split up the program into pieces of states that are independent. So my experience is that the big problem is state management, right? So the problem with state management is that you need to maintain things in your head, right? Like, so this is another thing I say often about programming and the difference between programmers and non-programmers. The difference between a programmer and a non-programmer. So if I take a non-programmer, I can get them to program things by putting together boxes and arrows, right? If I give them one of those languages that are data flow languages, and I have values that are plugged in into a plus, and they understand that it's going in, and et cetera, et cetera, anybody will be able to do that, whether they're a programmer or not. So they are doing a form of programming, but they're not. So does that make them real programmers? I don't think so. I think the test for are you a real programmer is I write you a loop, and that loop is updating things. It's like updating variables and whatnot. Can you play that in your head, right? That is what a programmer does, right? A programmer is kind of able to simulate what the memory is doing in their head. And it turns out that this is what's hard about programming. And it's so hard, in fact, that we only want to do it in a very local level. And then we want the overall structure to not work this way at all. I don't want this particular function to go modify some global state at the other end of the program, because then I cannot reason about it anymore. And so my experience with LLMs producing code is the following: is if you want good results, you want to split the state into independent pieces and then plug them together as a completely declarative graph of computation. And if you do that, that seems to work really
Is
well.
that so different from
Um,
how you'd try to decompose something for a team of human programmers?
I think so. I think a team of human programmers would be able to, human programmers do a lot of things when you think about it. Like, just think about a basic service, right? Like, so you have um, some request that comes in, right? And already just a moment where you listen and you accept the request. Well, there are a million races in there, right? Like, you accept this thing, you don't really know in what state you are. Maybe, multiple requests happens at the same time. So already your mind is dealing with a ton of stateful stuff and a ton of concurrency issues and we are so used to deal with those that, of course, we know what the right constructions and what the right trade-offs are, but that's the one thing where we are simulating it in our head, and we do that relatively well. And I suspect LLMs don't. Now, I might be wrong, but I suspect that the reason why, so my experience with an LLM, when you don't guardrail them enough, you don't force them into, a structure where it has to think about things locally. Basically, let's put it this way. You see React, how React works. React basically is a way of programming where you say, I'm going to show my intent, and I'm never going to worry about updates, right? I'm just going to say, if something has to change, then it will be another system, a framework that will take care of it. The only thing that I have to worry about is what shall I see on screen when I'm in this state, right? And so this has drastically simplified the writing of UIs, because what was hard about UIs was, well, whenever something changes, you have to go and update the state that you're in by hand, usually in the middle of some callback soup. And of course, you're going to get it wrong. And so when you didn't update properly something you were supposed to, you're now in this weird state that nobody understands, right? And so think of that kind of mental model, but generalized to programs in general, where it's not just for UIs, it's in general. You just want the LLM to be given a good goal, like here are the inputs, here are the outputs, don't worry about the updates, and then split it into smaller pieces, and then let another framework take care of the updates.
And I've known you long enough to
this is
sort of skip, as it were, ahead to some of the punchlines here, right? But what we were describing is kind of like a spreadsheet or something too, right? You're describing as one of the reasons sort of people that don't think of themselves as programmers have success building pretty complicated, really, applications, I would say, with spreadsheets, is because it doesn't present itself as programming. It presents itself as like, well, this thing is nothing but those values, and that thing is nothing but these values. And then there's this very thick runtime that sort of figures out exactly what needs to be recomputed when something changes. And so you're saying that you think I mean, out of curiosity, do you have like do you have any sort of case studies of this or anything? Like, have you like organically tried to get Opus or something to build something with just a big prompt versus building it with this kind of reactive scaffolding around it? And
yeah, we have a bunch of
okay,
benchmarks, but the benchmark. So what we did is we have a bunch of scenarios where we try to build it with Cloud Code 4.6. I don't think we've tried 4.7 yet. Codex and whatever. There's a bunch of different systems we are benchmarking against. The thing is, right now our numbers are very good, but most of the time is because Claude Code definitely gave up too soon. So it's difficult to make a good comparison, because if you just tell Claude, hey, build me this, basically it's going to build a crappy version that doesn't work at all, and it will tell you, oh, it's great and done, And so now you look great and you're like, oh, my system is so much better. But it's true that by tweaking the harness, you could probably get better results. Basically what you're doing, you're abstracting away everything that's hard, right? In a program, if I have inputs and I ask you to build outputs, especially for an LLM, when you think about it, because the LLM is going to think linearly like that, where I have my inputs, I have thought of intermediate steps, sorry. So I'm going to lay them down, and then I just keep on going until I reach the output. This is perfect for an LLM. That's everything an LLM loves, right? And then you abstracted away concurrency, all the kind updates, so it doesn't have to think about state ever. Cache invalidation. You abstracted away everything that was hard, right? And so, of course, if you compare it to a system, even a smarter system that has to do all these things from scratch, well, Yeah, good luck with that, right? So we see really good numbers. Like we've had, we tried it on hundreds of examples, and so far this approach is very
Interesting.
promising. So excited about
All right.
releasing it
Well,
soon.
if you want to, talk some more about it, go for it. If it's sort of still secret and you don't want to steal the thunder, you can also leave this as a teaser.
No, it's not
Okay.
secret at all. It will come out very soon, so there's no
Yeah. Well,
secret.
good, good,
Don't
good.
worry about it. And you're gonna love it.
Yeah, yeah. um, if I'm picking up what you're putting down correctly, you're hinting at a combined kind of like harness and framework that the harness targets, where that combined system makes it a lot easier to get good results.
And a type system. And that's the key too. It's a difficult balance. You need to find the subset of TypeScript that the agent is comfortable with, but at the same time, you want a subset that has good properties for you. And so finding that balance can be tricky because you will have a tendency to be too strict. But if you're too strict, then the LLM won't find a way to make it work, except if you give the right error messages. So, it's a bit like,
Interesting.
cooking. You're putting a little bit of salt, a little bit of this, and you're mixing until.
Are
But
error messages different? Like
yeah,
I remember error messages were a key thing for
very
hack
different.
acceptance. Like,
Yeah.
do LLMs want different errors?
Yeah, the kind of errors you give to an AI have to be different to those that you give to a human. And sometimes what the AI trips over is really weird. So, for example, there was this JavaScript class that has some kind of inner method and or inner capability. I don't remember what we were encoding exactly. And I figured, oh, you know what would be easy? To encode that with a method. So I'm going to add this fake method that does the thing that I want, and I'll be able to, put the declaration for it. And I'm just going to tell the AI to ignore it. And I'm going to say, I'm going to put a comment there that's saying, don't use this. This is all internal. And the AI just kept
Yeah.
on using it. So then I changed the name of this method, and I was thinking of Erling. I don't know if you remember Erling. He had inner things within Facebook that were called "Do not call me or
Right,
you'll
right,
be
right.
fired." And so I used something like that. I was like, "Do not use this under any
Right.
circumstances." Right?
Like,
Never
or
call
human
this.
lives will be lost, death is forever. Yeah, yeah, yeah. I just
Yeah, and it still did. It still called the thing, and it's like, but you have a comment that says never
right, right.
use this. You have this thing that says it's called never call me, and you're still calling it. Like, can you not see? So yeah, we just removed this way of doing thing because this was not working. Another example was, human beings don't like noise. So usually when you craft an error message for them, if it starts to be too long, they basically give up and it's just noise to them, and it's not a good error message if there's
Yep,
too
yep.
much information. That is not true for an AI. Most AIs actually are happy with more information. They'll be able to quickly determine which part they're actually interested in. So you'll consume more tokens, so you've got to be careful with that. But other than that, longer error messages with more context are good. And I would also say that for some reason, the AI is not very comfortable with variance. So I don't know if it's because TypeScript typically doesn't have variance.
Yeah, like, let's define variant here.
So imagine I have a collection of A's and I have a collection of B's, and I have A that's subtype of B, right? And I want to know if collection of B is subtype of collection of A, right? If I know that B is subtype of A. Well, that's only going to be true if the collection is covariant, meaning if it can support the thing that it holds to become narrower and narrower. I mean, wider and wider, depending on which direction you look, right? And contravariant is the exact opposite.
Covariance and contravariance is like the monad of generic programming or whatever. Like, everybody, first of all, like, it's a filter for like
Okay, so
whether you're in the fraternity or not, and secondly, like, everybody has their own way of explaining it. So, like, is it like a burrito? Is it like the spacesuit
okay,
on an astronaut? Or
it's like a burrito, exactly. So I'll go with a classic way of explaining it, and then I'll give you my way of explaining it. So the classic way of explaining it is whenever you have an object, you have the things that are coming in the object, and you have the things that are coming out of the object. And the idea is whenever something is coming in inside the object, it's always okay to give anything that's coming in something that is more precise.
If you have something that wants a vector of shapes, it's okay to give it a vector of squares.
Exactly. And for stuff that's coming out, it's always okay to consider it as less precise. So the thing is producing a vector of squares, and you're like, yeah, but I want to consider it as a vector of shapes, right? That's fine. And so that's one way of looking at it, right? What's coming in is contravariant. What's going out is covariant. In fact, I believe in C#, that's actually how they annotate the generics with in and out to say if they're co or contravariant. Usually plus is the sign for covariant and minus for contravariant, but just notations. The way I like to explain it is the following way. You imagine you have a function or a method, it doesn't really matter. You have a function and it has annotations on the parameters, and it also has annotations on its return type, right? And I claim that those two annotations are of very, very, very different in nature. So if I look at those two annotations, they're both annotations, but they mean very different things. So imagine I have a function that has an argument and that takes an int, a number as an argument, and produces a number as an output. Those two numbers mean different things. When it's the number for the argument, what I'm saying is, you better give me a number. You better give me a number, because if you don't give me a number, this function will just do horrible things, crash, and we don't know what's going to happen, right? And for the output, it's different. For the output, it's the function telling you, yeah, this is a number. You can trust me. Trust me, I produced a number, right? And so if I were to describe it as best as I could, I would say the parameter is a constraint. You're telling the rest of the world, I want this to be a number. And the return type is a fact. You're telling the rest of the world, this is a number, trust me, right? So, and if you think about it in these terms, you never get variance wrong, because then you think, okay, this is a constraint. Since it's a constraint, can I give it something that is even more constrained? Yeah, of course you can. You can constrain more and just, that's fine. It will still work as long as the constraints that the function was asking for are there. So if you are a number and something else, like you are an even number, that works. You're a number. Great, And the other way around, when it's a fact, somebody tells you, I actually gave you this object B, and I'm telling you it's a B, but it turns out B is also A. You're like, well, let's forget about the fact that it's a B. I just need it to be an A. And if you think about it in these terms, I feel like you never forget, you can always retrieve what co-contrariant means. And so,
and for listeners at home, by the way,
typically,
I just want to say, I personally need to go look up which one is code, which is contra every time I'm trying to have this discussion. The world makes sense, it turns out. There is this sort of strange thing about containment and subtypes. But what you want to have true is usually what your type system in a language that makes any sense and that people actually use also demands. And I'm curious, the people make mistakes with this too, I guess, is one of the things that you've observed, right? It's one of the reasons we end up talking about this stuff, is because people make these mistakes where they, promise you a vector of squares, but actually returning a vector of shapes, and they kind of scratch their heads about it, right? Are you finding that, you're saying LLMs have problems too? Is it the same kinds of problems that humans have, or is it a weird kind of alien set of problems with it?
I don't know how much of it is because the LLM has been trained in TypeScript, and TypeScript does not enforce any variance whatsoever. So in TypeScript, they have this unsound by design approach where they consider everything to be bivariant. So as long as there's a typing relationship between objects, they will accept it. So for example, you have a method, you want to redefine that method with something that should not be accepted because let's say, the return type is less precise or something like that. TypeScript just lets it flow. It just says, okay, yeah, and just run the thing. And so I don't know because I haven't tested enough an LLM against a language like Java to be able to answer that question. Is just that LLMs are struggling with
Right.
variance in general, or are they struggling just with TypeScript? So this I don't have the answer, but I do know that they're struggling with TypeScript. And yeah, the way we fixed it was with a lot more hand holding, right? Like with a lot more. So a typical case in TypeScript is that you expect a lot of covariance naturally when in fact it's completely incorrect. So for example, you are writing a program in TypeScript and let's say you said that you return, you know, uh, an object that has some amount of fields, right? And then you want to pass something that has more fields or has fields that are more precise or something like that. And you return it and you expect that there's a subtyping relationship there, right? Except that this subtyping relationship only exists if the fields are read-only. Because if the fields are writable, then that relationship does not exist, right? I could take my object, then hold on to a reference of the more precise field, then store that somewhere, then upcast it, and then, bad things will happen. Now, this is very subtle, and that's something where the AI needed help. Whereas, like, typically the error message says, if you made this field read only, the problem would go away. And things of the sort. So that is not too different from what you would see with a human being. And I'll fully admit that we're still at the very beginning of exploring all of that, but it is fascinating to see, how amazingly good AIs can be, and then how amazingly stupid they sometimes are. Like I've seen them this story with a method, like this method is called never call this
Right.
method. It's a mistake and you're still calling it. Like, how else do you want me to put this? So yeah, so far it has been a
The thing with
fascinating journey.
with the identifier names, like it just sort of treating them as little tokens and moving them around or whatever. It's actually an interesting thing. Like I think one of the reasons LLMs kind of had to go all the way through natural language to get kind of good at programming in practice is like the names of identifiers is actually a lot of how we navigate and a lot of how we handle things as humans. And I remember like when Copilot was relatively new, when Copilot was young, I was playing around with a code base that was like a unfinished implementation of a database. It was like a weird database implementation strategy, and I wanted to, and it didn't have joins yet, and so I wanted to like, make an outer join node or whatever. And I was kind of like, class outer join inherits from like expression node or whatever, or inherits, and left curly brace. And I was kind of surprised that Copilot was like happy to kind of fill in the body of that because it was like, oh, it's an outer join. Okay, cool. I understand how this database organizes things. Let me do the nested loop or whatever, and I'll just do the naive, explode the two things join.
So was it the quadratic version or was
Like
it the
use a
more?
strategy or
Yeah,
anything.
okay.
But it was still like really impressive to me. Do you know what I mean? I was still sort of basically expecting autocomplete, right? I was still kind of expecting something that was like, okay, I can do an expression at a time or a statement at a time or something. And this is one of the first sort of full method bodies I'd seen it just plop out. And it definitely was like the only clue it had was the name. Like the only clue it had was like that this was my intent. Um, but it's interesting that it's like not able to self-review the, don't call me or you'll be fired, people will die, death is forever, I'm serious, like one of the odd things about the implementation of an LLM is that the actual neural LLM like naturally outputs a distribution, right? It doesn't tell you which thing to select. You actually have to make some sort of sampling strategy. And if you roll one of these things by hand, like just build it all by yourself, and then just do greedy sampling, right? Like say you always pick the most common token, for instance. That doesn't work, it turns out. Like you get these crappy things that say things like I don't know, 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 for instance. And so the strategy for sampling for these things ends up having all these heuristics inside of it. Well, like one of the ones that works a little bit better is like actually good old fashioned beam search, right? Beam search from, a heuristic search algorithm from the 70s or whenever the good old fashioned AI people came up with it, where you've got, some set of candidates and you've got some scoring function for which candidates are plausible, and you kind of move each of them forward one step and say, okay, this beam looks better, and you cleave this one and expand this one or whatever. I remember in the early days of LLMs, like you'd have to, Gemini did this in particular, like the early versions of Gemini, if you asked it to just output JSON, it would be like, okie doke, here's some JSON, and you're like, and you could be like, no, seriously, I need just the JSON. I don't want to strip leading text. You need to start with a curly brace, JSON, please. It'd be like, I understand, you just want the JSON, here it is. And the curly brace. And that strategy of like actually threatening that sort of like cities will burn and lives are on the line, and I'm not kidding here, that would finally get it to like just be like left curly brace. Like, but anyway, the thing about that sampling strategy is like if you're building a formal language, like let's say you really want JSON output, right? We got grammars for JSON. One of the things a grammar can tell you is like which characters are possible here. Right? It's, it doesn't even make sense to have a left curly brace here because we haven't opened a curly brace yet. And as far as I know, I don't know of a lot of people that have tried to build a hybrid system like that where they're like, hey.
No, they are. There are even some people who are building type checking on the fly. So as the tokens are coming out.
So you have a whole incremental semantic system or whatever that's doing the whole formal language thing. Who's doing that out of curiosity? Do you know? Is it just you guys?
No, that's not us. But I can find the paper for you.
That'd be fun.
I'm really bad with names. But it's interesting with a threat because I know a friend of mine who's doing that with ChatGPT. So she's not using it for coding whatsoever. She uses it to, do her daily stuff. And she tells me whenever ChatGPT is not doing what I ask or is being sloppy about something, I say, be careful because I'll go to Claude. so she's just threatening the AI, like, I'm going to competition if you don't take this seriously. And I'm like, is this working? I'm like, I don't know, but I try.
Well, and that's maybe there's an interesting place for a thing we haven't touched on at all here too, about like the economics of building these things, which, they're very expensive artifacts to build. And sitting here talking to you in, April 2026, there are basically two coding models that are clearly at the frontier, and they're Codex and Claude, right? And, Opus 4.7 specifically and GPT-5.4 specifically.
Did you try the latest model from Meta? I haven't tried it yet.
My impression is that that MuseSpark is like good and like a cut above Llama 4 and stuff, but that it's not, correct me if I'm wrong, but I think it's like in that open source model kind of like category, which is increasingly impressive, to be clear.
It's impressive. Yeah, it's really good. Like Gwen 3.5 is good.
All of those coding models, like all the models that are sort of vaguely competitive at coding, aren't just playing predict the next token anymore, right? They're all RL'd, right? They all have also, after being pre-trained on a bunch of predict the next token, they are the winners of some complicated tournament that your model builder ran. And that tournament was, scored on do these coding problems well, right? And there's interesting tricks for how they augment the set of problems and how they, there's a kind of universe of not very public information out there.
Which is still how a bunch of stuff works, right? Like a chess engine pretty much still works this way.
Yeah. Well, and by the way, for what it's worth, like the bleeding edge chess things are all like this now too. They all learn through self-play. They're neural. They don't sort of, it's not tree search running a heuristic after 7 flies deep or whatever anymore. I mention this because I perceive there to be a big gap between what I trust Opus 4.7 with in coding and what I trust even, say, the Quen models with. And there's a possibility that there's a data flywheel running that keeps that gap big because, I and lots of other corporations are sitting there sort of trusting the best, scariest work to these models, and then giving them feedback, right? Then sort of telling them, no, not like that. You need to do this other thing. Or if it's not me giving them feedback, it's the compiler giving them feedback or the type checker giving them feedback. And one of the things I'm wondering is whether there's a kind of escape velocity that's been reached there where, once you have one of the best coding models, you also start to get a data moat that makes your model better and better. And this isn't even like a self-improvement loop argument, or this isn't even sort of like a sci-fi scenario where they paperclip us all and, start building nuclear reactors. This is just sort of regular old coding benchmarks. And the question is like, is there a natural monopoly here? Or seemingly duopoly so far, but like, does it become almost impossible for a new entrant to enter if you don't have a million people prompting their agents to make your model generate better code?
I don't know. Fear the other way around. I fear that the open source models are very close. And I mean, it's true that Mythos seems to be doing really well on detecting, vulnerabilities, but that's a very different class of problems. And I'm not very surprised that it does, and an LLM would do well at that. So I was on the security team at Facebook for 2 years, but although I wasn't a security expert, I was building analysis to find security holes. But I was in a team with a bunch of security experts, and I would see how they would operate. And the way they operate is they have a lot of patterns in their minds, and of known attacks, and they read a lot of code. And usually the stuff that they're looking for is a variant of an attack that they already know, right? Now, they can, if they sit down and find something interesting, try to craft a new attack, a completely new kind of attack. This happens, but this is relatively rare. What is more common is this is a variant of this known attack,
Yeah.
etc., etc. Like in chess, right? Like you have variants of things that you already know, right? And so an LLM is at an incredible advantage there. It has an exhaustive knowledge of all the attacks that were ever done ever, and is very good at recognizing patterns. And it can read a ton of code much, much, much faster than any human being or other human being would. So it seems to me that an LLM is perfectly positioned to, completely obliterate a human being at finding security holes. So I'm not surprised that it's doing how it's doing. However, if you look at the evolution in terms of, coding skills, it's getting better, but given the amount of hardware that was thrown at the problem, it seems that we seem to be getting a diminishing return, right? Like where you throw 10x the amount of hardware, although I don't know what the exact number is. I don't work for those companies. But derived from the price of the token.
Yeah. H100s cost a certain amount per hour and so on. Yeah.
Exactly. Um, it seems that they're getting marginally better on the coding tasks. And so my worry is that they're going to hit a wall. And when they hit that, if they hit that wall, because I don't have a crystal ball, and I tend to be wrong on these AI stuff, so don't listen. So yeah, I should have started with don't listen to me. I'm always wrong at predicting these kind of things. So my opinion doesn't matter. But I'd say one risk is they're going to hit a wall, and then the open source models are really not far behind, right? I think they're 6 months behind now. We have which one is it?
Oh, Kimi.
Kimi.
And they are an example of a company that does have a bunch of usage data too, right? So Cursor, has people banging on the keyboards in their product, and they
Yeah,
are one of the few people. It's not a model
yeah,
provider.
yeah.
As providing an IDE or an agent is a different way to get these traces. If you are not,
So I'm less worried about having Anthropic or Codex or Gemini. Gemini is actually pretty good. We should have 3 serious models because Gemini is a serious one too. I'm less worried about having one of these three escape with so much data that nobody can catch them, as I am more of they hit a wall and then the open source models catch up. that's why I think they're trying to build all sorts of things based on Anthropic, on Claude. They're going after everything, right? They're building a security analyzer. They're building, I think, a competitor for Lovable. They're building, and so the idea is try to get a captive audience that uses their model, right? Because if they stay with a model that they have today, their audience is not captive. And the reason is Claude Code is not intrusive enough, which is a
Yep.
good
Yeah.
thing. And this is also why it was so popular, right? Like you have a code base, you use Claude Code, it modifies your code base. It's great. Everybody wants to adopt that because it's not intrusive, right? But the downside is if somebody builds anything that's better than Claude Code, you're just
Yep.
going to
Yep.
switch to it. You're not captive at all. You're just going to go, all right, well, done with Claude Code. Thank you very much. And so I think their strategy is to build all sorts of products that use Claude, behind the scenes to try to have a captive audience. That makes sense. Yeah, I'm more worried about that. And then I'm worried about what does it mean, in terms of for the market, right? Like if those big AIs companies, so namely OpenAI or Anthropic, hit a wall, and they hit a wall meaning they can throw as much money and as much hardware as they want at the problem, and they don't seem to be able to build better models or significantly better models, what happens to their business model, right? I think Anthropic is probably in better shape, I believe, than OpenAI because OpenAI is burning a lot more cash. And then the open source models are right behind them. So it will be interesting. But maybe I'm off. Maybe they will just keep on getting better and better, and a new breakthrough will come.
Yeah. It's an interesting empirical question. I think like one of the things that I've always been blown away by just in the computer industry in general, as a whole 25 years I've been in it, is how quickly innovation diffuses, right? It's just how quickly like the presence of a patent or the fact that something's secret or somebody's some business has a huge advantage around a technique, like people still talk and switch jobs and allude to things and say things they shouldn't say in interviews and write blog posts that constrain what the solution must be and blah blah blah, and people kind of figure it out. I mean, I think when there was a moment about a year ago when DeepSeek R1 first came out, and it was the first sort of open source reasoning model that was worth a darn, right? It was the first open source reasoning model that really kind of could compete in any real way with O1, and it was sort of right before, if I remember right, O3 was released. And so there was this kind of overlap moment where you were like, well, do I feel like using O1 or do I feel like using DeepSeek R1? Depends, right? O1, I give all my tokens to OpenAI. DeepSeek R1, I have it say strange things about Tiananmen Square if I make the mistake of asking about Tiananmen Square. But yeah, otherwise, pretty good. By the way, if you've never done this experiment of like chatting with the Chinese open weights model about like why communism failed, or any of the things that you're like not allowed to talk about with a Chinese open weight model, you owe it to yourself. Like there's this very crudely fine tuned like jackboots clacking on a parquet floor answer you get that's like, actually communism is working amazing in the People's Republic of China and they've figured out everything out about it. Common misconception, communism alive and well. Anyway. But so there was this, there is, and when you talked with the people who actually like worked on O1 a little bit, and I won't name names or anything, but like it's a small city and people hang out, right? And if you talk with people who kind of worked on O1 and you're like, hey, like how surprised are you that this was like only a 6-month moat, right? Because chain of thought was like, there'd been like some papers written about it, but it wasn't clear that this was like something that was going to really work really well. And it was throwing a ton more compute at the problem, right? Because you're basically just thinking by like having the monologue, like by having the model have an inner monologue, having it like sit there and be like, okay, the user wants me to do this. I can't do this because, if you look at the token usage, it's incredible, right? So it wasn't very obvious that this was going to work well. They built this thing that did work very well empirically, that, cooked a bunch of benchmarks when it was first released. It had that space all to itself for quite a while. And then this open weights thing came out that, did all those things and more. And they had this I'll say the DeepSeek people like actually wrote a great paper about it too. They like were very open about all the pre-training, all the mid-training, all the post-training, like, there are recipes you could follow. And it kind of moved forward like what open weight models could do really quickly. And if you ask like how surprising that was, like most people that actually worked on one were like, yeah, of course, like people are going to figure this out. Like, of course, like once you, it's the 4 minute mile, right? Like once you put something out there, there's only so many ways it could be working and they're going to figure it out. And O1 even like did stuff to try to prevent distillation, right? Like initially, like it was launched in a way where you couldn't see the thinking tokens, you know, because they were worried about people just like training a model on its thought traces, you know. And still, it's still just a couple months. So I think broadly, as long as the frontier keeps moving forward at, you know, at the rate that it's been moving forward, there is going to be this gap. It doesn't seem likely that the gap gets any bigger than 6 months. And you're right. Like if there is a hiccup or there's a wall we hit, then things get interesting. There was this little interlude that sort of is forgotten when like GPT-4 was released, where first of all, there was a long time where GPT-4 was like alone in the world, where it was just the only thing that was anywhere near as good as it was. And it was at least possible that OpenAI like had some secret sauce. Like it was possible that they really, really knew something that they weren't saying that nobody else knew. And then, you know, like the Claude 3 family models kind of came out and they were closer and eventually was clear, and then the open source models came caught up and so on. And I think during that interlude, I entertained the idea maybe this is it, right? Like we've boiled the ocean, right? We've read all the stuff on the web. This paradigm of like gigantic data sets is the only thing we know works really well. Scaling laws say the models are big enough now. It's not like you can just build a bigger model. You need more data somehow. And where are you going to get the data from? And maybe we're just kind of cooked this way. In practice, that seems to not be true from a bunch of different angles. Like people have been more creative about finding more data than I expected. There are ways to get things that aren't just the public web. Um, and also there have been these new paradigms like chain of thought and reinforcement learning and so on that have been pretty successful and have a lot of legs. So I think like the absolute amount of human ingenuity going into moving that frontier forward and its track record of success so far has me a little uh you know, has me a little bit in awe right now. I'm just kind of I'm grateful to be one of the consumers that like benefits from these things getting better so quickly. Um, to me, I think there was a chance. Uh, like I think there's a chance that sort of the self improvement loop gets closed around coding models if you get a big enough data moat around it. And I think you know I'm talking to you a day after the news about XAI having this kind of bizarre deal with Cursor to potentially acquire them, to have the option to acquire them later, where basically they're going to get a bunch of programming traces in the deal. Is what's going to happen. They're going to get a bunch of usage traces of their coding model. Because I would, you know, interpolating a few steps, I think XAI perceives itself as behind in the coding model race. They're correct; they are behind. Nobody is choosing to use Grok to code with that I know of, unless you work for XAI. And they're betting that like this data set is going to be is basically impossible to innovate your way around. That like unless you have this data set, you can't really compete with it. And those open source models that you're referring to, you know, soon before their release anyway, Anthropic started making a lot of noise about Chinese model builders doing distillation attacks on their models, or what they term as distillation attacks on their models. And I honestly don't. I'm agnostic about whether that counts as an attack or not. Right?
No, but I think that's the key missing in your narrative. I think you covered everything. The one thing that's missing is up until now, when you know a company had a secret sauce, um, it could you know use that secret sauce to dominate the market, and then once it was dominating a market, it had enough data and enough you know presence that it was impossible to beat. So a good example is Google, right? It had a secret sauce. It knew how to index the web efficiently and rank pages well, and it produced much better result than everything that was out there and much faster. And then eventually it was basically covering everything and everybody was using it all the time for everything, so much that it became a verb, like Googling something, right? And now if you want to go after Google, well, it's going to be very, very hard because it's going to be difficult to get the data. It's going to be difficult to, you know, even get in front of users, right? Like everybody has used. The key difference here is imagine if Google was built at the time Google was built, a very powerful foreign government who will stop at nothing would not have wanted an American leading that space. That would have been very, very different because I don't know what, and here, everybody probably guessed that I'm talking about the Chinese government, but maybe not only. There might be other governments who don't want to see, an AI that is almighty in the hands of an American company, and maybe they want their own thing. So the odds that, more than one foreign government have spies working for OpenAI and
No,
Anthropic.
that's a literal certainty, right? I'm sure those companies operate with probability one. Yeah, yeah,
it's yeah,
yeah, yeah.
we're pretty close to certain that this is the case, and then so now it's a completely different deal. If you have very powerful foreign countries who will stop at nothing to build the same thing as what you're doing and don't care about the viability as a product of that thing, right? All they want is for it to work, and if it's open source and everybody can use it, so be it, right? They just want your product to not be in the hands of an American company. That is a difficult thing to compete with. I mean, the only way you have is to keep on innovating, moving forward fast enough that they play catch up and never hiccup, certainly not a wall, because otherwise, they're waiting. And from their perspective, if I was, a foreign government trying to play catch up with those AIs, you could say, well, look at those stupid Americans spending all that money on, cutting edge stuff that we'll get for free because we're going to make a copy of it for a fraction of the cost 3 months later. And thank you, Americans, for spending all that money, doing all the hard work for us. So I hope it's not how it goes down. And I hope those companies find a way
Yep,
to
yep.
keep an edge and, benefit from all that, all that work they did, because I'd like to think that those who put the work get the benefit of the work. But it's, it's a tricky situation.
Reasonable people can disagree about how they view kind of Anthropic's positioning of Mythos as like too dangerous for general release. I think we have a AI research intern at Pebblebed named Jenny Chu. She was sort of finding some of these same CVEs, with publicly available models and sort of a little bit of jailbreaking and clever prompting. We also have a portfolio company called Vidoc. They're a Polish security company, and they did some numbers last week kind of demonstrating how to find these vulns with GPT-5.4 and with previous generation Opus models. So I mean, it could be that there's elements of this positioning of Mythos that are kind of marketing, right? There's elements of it that are, hey, we've got the super secret AI, and it's like just not economically viable to sell it yet. So they're just kind of highlighting its capabilities. But taking it at face value for a second, it's at least possible that there was a window there where the company Anthropic, and the subset of people doing vulnerability research using the new methods, using Mythos and finding these bugs, where basically it had a kind of super weapon, right? Where it had something that would let them disrupt any country's power grid, um, get into sensitive and national security sensitive systems in those countries. There's a way in which like they had a capability that threatens the infrastructure of the entire world. So there's an argument that if you take Anthropic at their word, it's sort of a better, more stable universe if they're not the only entity on Earth that has this capability. And I'm not sure which one they want us to believe, right? Like if they want me to believe that Anthropic, this PBC in California that has a very particular set of people and is privately held, should be able to sort of decide who lives and who dies in this way. Um, they seem like lovely people. I'm sure they take that responsibility seriously, but I'd rather have it be kind of the global order, for all of its faults, deciding those things. So
Yeah, I don't know. They definitely want you to think of them as the good guys. And that might be because they are, you know, that's one explanation. And another explanation is that it's a marketing stunt and really they don't have, as you said, like, I mean, there are many possible explanations. One of them is there's not enough money to run the model as it is. or it would cost way too much to release Mythos now. And if we did, then especially given, I believe today's tokens are heavily subsidized. And so if the cost goes up significantly, that means you have to burn a lot more cash just to keep
Could you
things
imagine a
going.
strange world where they just charge $200 a token or something and say like, have at it if it's really that important to you?
The problem with this stuff is that you will probably lose the data. So what you also want is to make your model better, and to make your model better, people have to keep on using it. And so if you make it too expensive so that nobody uses it except for niche cases, you loses the data that could have made your model better. Because what you are especially interested in is your model was trying to do something and it didn't work. And then the user complains and say, well, this is not working. This is not where you're supposed. This is gold to you, right? Because now you know where it's not working and how you're going to make it better.
I mean, actually that is an interesting economic moment that Anthropic's into, which is they have one of the frontier models in market and a successor in the wings, and so like they're getting all the traces from people using their leading edge commercial publicly available model anyway.
Yeah, but the two might not be the same, right? I think maybe what helps Mythos is not the same as what's helping 4.6, 4.7. We don't know that, right?
One of the things that is described in the Mythos write-up, and that I think I saw a little bit with Jenny as well, is that you can just kind of compute more and you will find more of these bugs. Like it's not clear if you like look at the CVE density of changes to the Linux kernel so far. Like one of the things Jenny did was just build a data set that's like all 200,000 or so, 120,000 commits to Linux over the last 27 years or whatever. And then go into the CVE database and label all the ones that were CVEs. And it's like 8%. Like one check-in in 12, right? And Linux is supposed to be this very elitist, very high standard, lots of eyes make all bugs shallow, right? One of the most kind of inspected open source projects out there. Your project is probably not as high quality as the Linux kernel. Nothing personal, whatever your project is. And the sheer defect density, I think, is really surprising to me. Just the prior probability of you introducing a CVE being 1 in 12 is a lot higher than I'd have guessed. And so this is all to kind of say, like, there could be a future where the way that your software is secure is that you spent more on tokens to pen test it, right? We're kind of and that's a strange world. It makes it. I've been assuming that having all these coding agents is going to mean we're going to run massively more custom software because like now it's so cheap to produce and so wonderful to produce.
So do we know what Mythos is doing differently?
The impression is just that, I mean, the kind of public narrative is just bigger and better. It's just this 10x bigger thing. They did a lot of test time compute when finding these attacks. So this thing sat there and really, really churned, and probably had some tree of like approaches and whatever that it was using. But all that said, like, it could be that there's a perverse dynamic here where you actually want to use the most resourced people's software. Like you want to use software from the biggest org because they're able to make it more secure, at least if you're a security critical application. Another possible way this game theory breaks out is like it gets so cheap to produce lean 4 proofs of correctness along with your code that like we're all fine, right? We all just like live in a.
Yeah, I really don't think that's going to be the case. But for the kernel, yeah, it's surprising. It's interesting and surprising. But I'm not surprised that LLMs are very good at finding security holes for all the reasons I mentioned earlier. A lot of security holes is about finding a pattern that matches an attack that you've seen before and try to tweak it to make it work in this context. And so if you know all the
Yeah.
attacks, ever produced by mankind, and you read code really, really fast, well, the fact that you're able to, was it be able to, was it be able to find attacks without the source code? Do you know?
I think the thing that kind of got people's attention was that these attacks were often like multi-step, right? They involved like chaining together lots of different vulnerabilities to get to something practically exploitable. So it wasn't just like, okay, there was a Stack Overflow here and maybe it crashes or whatever. It was like, no, it used that to put this thing here and it used this thing there to corrupt this thing and it used the fact that this thing was corrupted to make that thing vulnerable, and then you could actually attack it from the outside, kind of thing. And I think that was where a lot of the test time compute went to, was that it would like, it was kind of playing a game of chess, right? It was kind of trying to move the state of the compromise forward multiple steps.
Which is what usually happens in an attack, right? Like you found a way in, now you want to escalate. In fact, I know that most attackers, for example, a good thing if you are in a company and you want to keep your company safe, one good thing to do is to add a ton of alarm bells in case somebody is
Mm,
reading
mm,
your own security material. So when an attacker gains access to a company, the first thing they wanna know is how the security of the company works. So they're gonna jump on the wiki of the company and try to read, the security briefings and how,
yeah,
what kind
yeah.
of, and so logging that is gold, right? Like if somebody that, for example, has been in the company for a year, so no reason, if they've been in the company for 2 days and they just arrived and they're reading the wiki on security, then great. But if it's a company who's somebody who's been in the company for a while and their job has nothing to do with that, right? Like they are working in marketing and here they are reading about like something fishy is going on there. So that's it was fascinating to me how much security was also about um human engineering, like trying to understand how humans were going to uh what their next move was going to be and try to detect them more than prevent them from doing things. So there was a vicious one. So there's a few vicious things that
Yeah,
Erling, the guy who was working with, I mentioned him before, a very, very smart guy, Erling Ellingson.
we'd have said cracked if that was like in common parlance at the time. I think of Erling as kind of having, his portrait in the dictionary next to cracked for the modern definition of cracked.
Yeah, yeah, he
Yeah,
is
yeah.
he is something else. Like when it comes to security, he clearly has. So he had a few funny stories where he left some, I think they're called honeypots, right? And usually a honeypot is you leave something that looks like the attacker was able to get something. So for example, they were able to SSH into something, and they're going to jump on that because now they think they have access to a machine. And the difference is that his was super sophisticated, where he really made them think for a
Yeah, yeah.
very long time that they actually hacked Facebook. And then he had all sorts of, really twisted things. Like, so for example, he gave them access to the source code, but he changed all the E's with a UTF-8 symbol that looks exactly like an E,
Right, right,
except
right.
that if they tried to run it, it would not run. But they could not actually debug what was going on. The only thing they could know is that, they could change the code and try to make it run. And so he was
Yeah, yeah.
like, really enjoying this. He's like, so they're going to see the source code. They're going to be like, great. And then they'll try to make changes and make it work. They won't realize that the E's are not E's and it's not going to work. And, it was full of stories like that. And yeah, so I guess back to the point, I think models like Mythos are going to be useful, but I think, again, we're going to need a ton of human beings who know how this stuff works and have built these kind of systems before and are able to, bulletproof, what the different things are. And when it comes to marketing versus reality, I don't know. I suspect a bit of both. If I had, a system that was capable like that, I would try to make a marketing stunt out of it, because why not? It's also a company that's trying to get attention, even though it already has a lot of attention. No, what's more interesting to me is where are the metas of the world going to be? How is Google going to react? Because Google feels a little bit behind now. and I don't believe these two companies are willing to give up. So,
Yep.
they spent a
Yep.
lot of money on this stuff, catching up. There's also, you mentioned XAI. So it's going to be interesting to see. I mean, they have a big advantage, and that's that they
Yep.
have a
Yep.
huge money making machine behind them, right? So the difference with OpenAI and Anthropic is that they need investors to give them money, and they need to burn that money to get ahead.
The company formerly known as yeah, yeah. But I think we did you work there as Meta? Was it Meta on your badge at any point?
When was Meta? Was it 2000? I left in
I think so. Yeah.
2019. So yeah, I must have worked there as Meta. But it was so ingrained to me that it was Facebook that I had a hard time changing. So I think the difference is Facebook and Google are burning their own cash, and that is pretty much limitless as long as people are watching stuff on the internet and we can serve them ads, which I don't think is going away anytime soon. And yeah, Anthropic and OpenAI are burning, the cash of investors. And that's something that needs a return, a significant return on investment, which maybe they can pull off. And then there's, have you seen this stuff where Elon Musk wants to train models in space? So he wants to send data centers to space. That seems science fiction to me, but the guy has pulled off some pretty amazing
Yeah.
stuff,
Yeah.
right? Like you look at those rockets going in and out to space, and this is really impressive. And yet again, I mean, I am both very, very impressed with him with some things. He's a bit like an LLM to me, right? Very, very impressed with him with some things. And with others, I'm like, so he becomes the CEO of Twitter, and then he wants every single engineer to review how many lines of code they've written and what those lines were.
Why
And I
not?
think he was asking for people to print them. And you're like, well,
Yeah. Yeah.
I've written software for a while, and no, that's not how. Now, don't get me wrong. There is a possibility that Twitter was over-engineered, and that there was too many engineers there that you could actually run it with way less. So I'm not saying that every single engineer was necessary for the company to function. That's not what I'm saying. But evaluating that by asking them to show them how many lines of code they've written and print them out, that is weird.
Peter Thiel's kind of like this a little bit, right? Like I think like Peter Thiel has this very weird worldview that I will not attempt to summarize here, but like is not very consensus. And so he has a bunch of unusual positions on a bunch of topics, many of which I think are just wrong. But like his path through life, it's enough if 1 in 50 of them are extremely right. And if he's correct in places you're unlikely to be correct because of this weird worldview, then the weird worldview is kind of serving him. And I've never actually worked for Elon, but like my impression talking to folks that have worked with him relatively closely is like if there is one weird trick, it's sort of asking like why is this physically impossible? Right? Like first principle, let's go back to sort of every possible first principle. Like, why can't we do this crazy thing with data centers in space? Well, something about cooling. Okay, what needs to be true to solve this cooling problem? Well, I need some sort of material that can kind of like dissipate heat in the vacuum of space and blah, blah, blah. So, okay, great. So then what's missing? Like, does that material exist yet? Like, what do we need to, and eventually you kind of like get to the leaves of this tree and, there are a set of technical problems to solve and you can hire people with the right expertise and you can, get them excited to solve these problems that nobody else is able to solve. And if the problem's ambitious enough, they'll be excited and things happen. And I say that as somebody that like is actually agnostic about whether the like space data center thing makes sense or not. But that trick of kind of saying like, well, why can't you do this at all? It's been, arguably it's been successful in Neuralink. It's been successful, for Tesla, definitely been successful for SpaceX, probably the most dramatically for SpaceX.
Starlink too. I mean, the amount of success is incredible. It's very, very impressive what he's achieved. So yeah, no, I think. But when he was talking about software at the time where he acquired Twitter, I was like, no, that's not how you assess, the quality of, the output of a software engineer. But then again, people have different dimensions, and they can be extremely good at one, and maybe they have some blind spots on others, and that's completely fine.
Okay, well, like just to get something on tape here, thank you for joining us for this LLM focused edition of Coffee, Computers, and Beer. It's been a pleasure here talking with my friend Julian. And if you like this, remember to smash like and subscribe, and we'll see you next time.